Hello everyone, in this video we'll be talking about another category of enzyme inhibition, that is non-competitive inhibition, which is coming under reversible inhibition. So what is a non-competitive inhibition? So in our previous video we discussed about competitive inhibition. That means inhibitor is a structural analog of the substrate, so there is a huge competition between substrate and inhibitor to bind with the enzyme. But in non-competitive inhibition, there is no such competition. Why? Because the structure of inhibitor is totally different from the substrate. But still there is a happening of the inhibition. How it is possible? So let us discuss. So the inhibitor which is involved in non-competitive inhibition known as non-competitive inhibitor. And there is no competition between substrate and inhibitor. As I said, there is no structural related similarity between substrate and inhibitor, and inhibitor is usually structurally different. And the main prominent thing about non-competitive inhibition is, in competitive inhibition there is a competition between substrate and inhibitor to bind with the active site of the enzyme. But here inhibitor will bind to the enzyme rather than to the active site. So the inhibitor will not bind to the active site of the enzyme, but it will bind to the other than active site. Here the attachment of substrate, at the same time attachment of inhibitor is possible in case of non-competitive inhibitors or inhibition. Non-competitive inhibitors can bind to free enzymes or the enzyme substrate complex. There are two possibilities, because here inhibitor is not binding to the enzyme active site, so it is binding to other site. So here the non-competitive inhibitor can go and bind to free enzyme or enzyme inhibitor complex. Enzyme substrate complex, and to form enzyme inhibitor substrate complex. So enzyme inhibitor, there are possibility of two compound formations. One is, as it is going to this inhibitor is going to bind to free enzyme, it forms enzyme inhibitor complex, and otherwise it will go and bind to enzyme substrate complex to form enzyme inhibitor substrate complex. And however, enzyme inhibitor substrate complex doesn't continue to form the product. And non-competitive inhibitors lowers the concentration of functional enzymes, and non-competitive inhibition cannot be overcome by increasing the substrate concentration. So in case of competitive inhibition, if you raise the substrate concentration, you can reverse. But in case of non-competitive inhibition, if you raise the substrate concentration, as here inhibitors are not going to bind to the active site, there is no use if you increase the substrate concentration to reverse the inhibition. You see here, so the diagrammatic representation here, enzyme substrate, inhibitor is there. Here this inhibitor can bind to form enzyme inhibitor complex. That means inhibitor can go and bind to the free complex. So this is the active site. You see here, this inhibitor is not binding to the active site, but it is bind to the other than active site. And it forms enzyme inhibitor complex. And to this substrate will go and bind to form enzyme inhibitor substrate complex. And there is no reaction further, no product. Alright, so this is the mechanism about non-competitive inhibitors, how they work in non-competitive inhibition. So examples of non-competitive inhibitors are like ethanol, or certain narcotic drugs are non-competitive inhibitors of acid phosphatase, and trypsin inhibitors occurs in soybean, and raw egg white inhibits activity of trypsin, and Ascaris parasites contain pepsin and trypsin, like inhibitors inhibit action of pepsin and trypsin. So they are digestive enzymes, and these worms inhibit the production of pepsin and trypsin, and by inhibiting the enzymes in production. So coming to the kinetics of non-competitive inhibitors, so here the same thing. So we'll see the Lineweaver-Burke plot or double reciprocal plot. Here in case of competitive inhibition, what we have noted, there is no change in Vmax, and increase in Km value, right? But here there is no change in Km. Km is same, there is no change in Km, but Vmax has been altered. You see here the difference. So non-competitive inhibitor, there is a increase in Vmax value. There is change in Vmax value, that means the value of Vmax has been lowered. At the same time, Km, there is no change, it is constant. Coming to the next type of reversible inhibition, that is uncompetitive inhibition, and the type of inhibitor involved in uncompetitive inhibition is known as uncompetitive inhibitor. And as like in non-competitive inhibition, the inhibitor may go bind to the free enzyme and enzyme substrate complex, but here in uncompetitive inhibitor, the inhibitor can bind only to the enzyme substrate complex. It will not bind to the free enzyme. So now you can easily make out, in the competitive inhibition, there is a huge competition for active site of enzyme between substrate and inhibitor, okay, and it may form only enzyme inhibitor complex. But in case of non-competitive inhibition, the inhibitor will go and bind to the enzyme other than the active site. So there are two possibilities: it may bind with the free enzyme or it may bind with the enzyme substrate complex. But in uncompetitive inhibition, the inhibitor will go and bind only to the enzyme substrate complex, okay, and it doesn't have any affinity for free enzyme, okay. Enzyme substrate inhibitor complex doesn't continue to form any product. So uncompetitive inhibition, like, it cannot be overcome by addition of like non-competitive inhibition, because here they are not binding to the free enzyme, they are not binding to the active site, okay, they are binding to the other site, okay. So though if you increase the substrate concentration, this type of inhibition cannot be reversed, okay. Consequently, Vmax cannot be, when you are talking about the kinetics, enzyme kinetics about this particular type of inhibition, like reversible inhibition type uncompetitive inhibition, okay. Here Vmax cannot be attained even at high substrate concentration, okay. Vmax doesn't have any value here, okay. Vmax doesn't have any value here. When you see the diagrammatic representation, you see here enzyme substrate, first there is a formation of enzyme substrate complex, ES complex. To this enzyme inhibitor will combine and to form enzyme substrate inhibitor complex, and doesn't carry forward, and there is no product. So when you talk about the kinetics, as I mentioned, you see here Km value, that means both Vmax and Km, both values has been decreased, okay. You see here, this is a Vmax, okay, and Km value, both has been decreased, Km value and Vmax, both the value. In case of competitive inhibition, what happened? Km has been increased, Vmax unaltered. In case of non-competitive inhibition, what happened? Vmax has been decreased, Km unchanged. But here both Vmax and Km values has been decreased in case of uncompetitive inhibition or in presence of uncompetitive inhibitor. So coming to the examples, like herbicide glyphosate, okay, also known as Roundup, is an uncompetitive inhibitor of enzyme in the biosynthetic pathway of aromatic amino acids in bacteria, not in humans. Non-toxic animals because they lack enzymes, because it is non-toxic in animals because it is lacking the enzyme. So that's all about reversible inhibition, like types, competitive, non-competitive and uncompetitive. Thanks for listening. Thank you.